In this video, we're going to focus on radical equations. Radical equations are equations involving radicals in it, square root, cube root, fourth root, and so on. Our goal would be to isolate the radical and then raise both sides to the same power as the index. Here's the steps to solve radical equation. The first step is isolate the radical expression. Get it on one side of the equation by itself with all other terms on the other side. If two radicals are present, then get one radical on each side of equation. We will also see some examples with two radicals in there. Raise both sides of the equation to the power of index of the radical. So if we have a square root, we will raise both sides to the power 2. If we have a cube root, raise both sides to the power 3. Fourth root, raise both sides to the power 4, and so on. Solve the resulting equation. And then last step is really, really important. Check your answer by plugging back into the original equation. So your solution that you got, plug it back into the original equation that you started with to make sure the left and right hand side are equal to each other. It is common to get answers that are not truly solutions for the radical equations. Okay, these answers are called extraneous solutions. These solutions arise because of raising the equations on both sides to same power. These numbers may be solutions to the new equation but not to the original equation. Here's an example. How many solutions does square root of 25 equal to x have? Well, there's only one solution, which is 5. And how many solutions does 25 equal to x squared have? There's two solutions, 5 and negative 5. You can also look at it when the exponent is 1, there's going to be one solution. When the exponent is 2, there's two solutions. Those two solutions are not always different or distinct, but they could be repeating solutions, but the exponent tells me how many solutions I'm expecting. Now we know if we square both sides of the equation 1, then we get equation on the bottom. And for the equation of the bottom, we have two solutions, but only one of them is the solution to original equation that we had squared both sides. Okay? So that's why it's important to check your solutions. You might have extraneous solutions, which are solutions to the raised power equation, but not to the original square root or cube root or fourth root equation. Let's see some examples. Here's example number 1. Square root of x minus 3 equals 2. So I already have the square root alone on one side. I'm going to go ahead and square both sides. Square both sides. Okay. Go ahead and square both sides. So when I square both sides, I'm going to have square root of x minus 3 squared equals 2 squared. Square root and square are opposite operations. They cancel each other. So I'm only left with x minus 3 equals 4. X equals 4 plus 3, which is 7. Now, before I say this is my solution, I'm going to check. And make sure. Remember, we've talked about in the past, the answer to a square root is positive only. Answer to a square root is positive only, or any even root. Answer to an even root is positive only. Answer to an even root is positive only. All right, so x equals 7. So here, let's check. So I'm going to plug into the original equation. 7 minus 3, is that equal to 2? Square root of 4, yes, that is equal to 2. So left hand side is equal to right hand side. That means this is the correct solution, and I'm going to circle it, box it, highlight it, however you want to. Notate that this is your final solution. Example number 2, my first step would be to isolate the radical. So I'm going to subtract 7 from both sides. Square root of x minus 3 is 5, take away 7, which is negative 2. At this point, the bell should go off in my head. The answer to a square root is positive only. So I see the danger here, and I already see this is not going to work out. This is going to be a no solution. And you can stop right there and say no solution, because we do know answer to a square root is positive only. Let's say somebody forgets and they continue doing this problem. So you can go ahead and square both sides, which is unnecessary. You should stop here because you do see that square root equal to a negative number, which is not possible. We talked about it in the previous section. The answer to a square root is a positive only. Principal root is positive only. So in case somebody forgets and they go to the next step, square both sides. So x minus 3 squared equals negative 2 squared. Looks like it would be x minus 3 equals 4, x equals 7. Now when it's time to check the solution, let's see what happens when we are checking the solution. So go ahead and check the solution. Plug into the original equation. Always plug into the original equation. So 7 minus 3 plus 7 equals 5. So I'm putting the question mark because I don't know if left side is equal to right side. 7 minus 3 is 4. Square root of 4 is 2. 2 plus 7, is that equal to 5? 2 plus 7 is 9. It's not equal to 5. Thus, it does not work. And I can again see that this problem has no solution. There is no variable value. There's no value of x that will make the left and right hand side equal to each other. Here is the next example. Cube root of 2x minus 6 minus 4 equals 0. So here we are, cube root of 2x minus 6 equal to 4. Isolate the radical. That's the first step. Next step is cube both sides. Raise both sides to power 3 or cube both sides. So raise both sides to power 3. Why are we using power 3? Because the index is 3 and our goal is to get rid of the radical. If the index, only now I would be able to get rid of, because cube root of 2x minus 6, cube root and cube are opposite operations and they will cancel each other. So here we are, cube root and cube. 2x minus 6 is 64. 2x comes out to be 64 plus 6, which is 70. 2x comes out to be 70 divided by 2, which is 35. Now, in case of cube root, fifth root, it's not really necessary to check your answer, but it's always a nice thing to be, at peace when you know your solution is correct. You haven't made any mistakes. So I'm going to plug the 35 into 2 times 35 minus 6 minus 4. Is that equal to 0? So cube root of 70 minus 6 minus 4, that's cube root of 64 minus 4. Is that equal to 0? Yes, 4 minus 4 is equal to 0. So yes, this solution is correct, and I'm going to circle box x equals 35. Next example, number 4. Again, we are dealing with a square root here. So my first step is to isolate the square root. So I'm going to add 4 to both sides, which is 12. So I am left with 3x plus 3 equals 12. Now, once the square root is isolated, I'm going to square both sides. Go ahead and square both sides. This will leave me with 3x plus 3 because square root and square will cancel, equal to 12 squared, which is 144. So 3x plus 3 equals 144. 3x equals 144 minus 3 is 141. X is 141 divided by 3. 3 times 4 is 12, so it looks like it's going to be 47. And it is time for me to check my solution. So when we check, where do we plug it in? That's very important to keep in mind when it's time to check. You plug into your original equation, okay? I'm going to do the check work on the top because I'm kind of lacking the space. So for the check work, I'm going to plug 47 in the original equation. So 3 times 47 plus 3 minus 4, is that equal to 8? Well, I'm not sure. 3 times 47 is 141. 141 plus 3 minus 4, is that equal to 8? Well, not sure yet. So I have square root of 144 minus 4, is that equal to 8? Square root of 144 is 12 minus 4, is that equal to 8? Yes, left and right hand side are equal. So that means this is the correct answer. X equals 47 is my solution in this case. Next example, we have two radicals in the next example, and that's okay. If there's two radicals, then my goal would be to get one radical on each side. If there's two radicals on the left hand side, I would get one on the left side, get one on the right side. Or if I have two radicals on the right hand side, I would get one radical on the left side and one on the right side. Okay, but in example number 5, I already have one radical on each side. And nice thing, there's no other terms present than the radical itself on both sides, than the radicals and the radicands. Okay, so I'm going to go ahead and start by square both sides. So this will leave me with x plus 4 square root square equals 2x minus 5 square root squared. Now square root and square are opposite operation to each other. They're going to cancel each other, and we'd be left with x plus 4 equals 2x minus 5. It is my goal to isolate the variable, so I'm going to subtract the x from both sides. Doesn't matter which side you do that. 2x minus x is x minus 5. Now we would add 5 to both sides. 9 equals x. Before I say this is my solution, I must do the check work. Okay, so I'm going to go ahead and check. Always plug into the original equation, okay? When I do the check work, so I'm going to plug into the original equation. I'm going to replace x's by 9. Screen moved. X is by 9, so 9 plus 4, is that equal to 2 times 9 minus 5? Let's check. 9 plus 4 is 13. Square root of 13, is that equal to 2 times 9 is 18 minus 5. 18 minus 5 is also 13, and square root of 13 on the left side, square root of 13 on the right side, both left and right side are equal to each other. So we do have a solution here, and I'm going to go ahead and box this or highlight it. Let's check out our next example. They are going to get slightly harder. We're going to be bumping it up now. So two radicals with, this next one does not have two radicals, but we will see another example where there's two radicals with an extra term present on either side, or maybe both sides. So here we are. My goal is to isolate the radical first, and I'm going to go ahead and move the radical to the right hand side so that it becomes positive, and bring that negative 5 to the left hand side. So x minus negative 5 equals square root of 1 minus x, and this is going to be x plus 5 equals square root of 1 minus x. Okay, here we have the radical isolated. Now we're going to square both sides, square both sides. Okay, so we have x plus 5 squared equal to square root of 1 minus x squared. Now go ahead and square both sides. Very important to keep in mind, this is a binomial. It's not going to equal x squared plus 25. A very common mistake I see students make here is they will open up the bag, they will foil it. They won't foil it, but they would just say it's x squared plus 25. That's not the case. If you foil x plus 5 squared, it's going to be x squared plus 10x plus 25. On the right hand side, square root and square will cancel, and that would be 1 minus x. And now it's time to bring everything to one side. It looks like it's going to be a quadratic equation. So I'm going to carry everything to one side, add an x to both sides, that would be 11x. Subtract 1, that would be plus 24 equal to 0. Now think of two numbers. It's a quadratic equation, looks like it's factorable. Think of two numbers, then multiply to give you 24, add up to give you 11. They are 8 and 3. So my two solutions come out to be x equals negative 8 and negative 3. Now it is time to check these solutions. Now don't think that negative solutions are not okay. Okay, in previous example, I did say that answer to a square root is never negative. That's not what's happening over here. I don't have the square root isolated. So when it's time to plug your solutions in, plug into the original equation, not anywhere else into the original equation. Okay. let's see. So let's start by plugging negative 8 in there. So check x equals negative 8. So I'm going to go ahead and plug negative 8 into the left side and see if it gives me negative 5. So negative 8 minus square root of 1 minus negative 8. Is that equal to negative 5? Negative 8 minus square root of 1 plus 8. Is that equal to negative 5? Negative 8 minus square root of 9. Negative 8 minus 3. That is not equal to negative 5. So negative 8 did not work here. I already can see x equals negative 8 does not work. How about checking x equals negative 3? Would be negative 3 minus square root of 1 minus negative 3. Is that equal to negative 5? Negative 3 minus 1 plus 3, because two negatives will make a positive. That's negative 3 minus square root of 4. Negative 3 minus 2. Yes, that is equal to negative 5. So both left and right hand side are equal in this case. So only negative 3 is a solution. X equals negative 3 is a solution. Negative 8 is extraneous solution. That means that's not a solution. We would not include it. It's an extra solution, which is the solution to the equation that we obtained by raising both sides to the second power, but not a solution to the original equation. Okay, let's look at example number 7 now. I'm going to erase number 6 to give me more room for number 7. Or maybe just make the page bigger. That would help too. All right, here we go. So example number 7, we do have a radical, and I'm going to try to isolate the radical. 2x. So to isolate the radical, I would be subtracting 2x from both sides, okay? So square root of x plus 1 equals 8 minus 2x. Once the radical is isolated, I'm going to go ahead and square both sides. So x plus 1 square root equals 8 minus 2x. Go ahead and square both sides. Okay, square root and square is gone. X plus 1 equals 8 minus 2x, that is 64 minus 32x. Don't forget to FOIL it properly. A lot of students make a mistake at this step because they say this is 64 minus 4x squared, which is not correct. So make sure you FOIL correctly, okay, which is going to be 64 minus 32x plus 4x squared. Again, looks like it's a binomial equation. I'm going to bring everything to one side and get a 0 on the other side. So I'm going to subtract the x from both sides and kind of rearrange. 4x squared minus 33x. 64 minus 1 is 63 equal to 0. Okay, now looks like there's no common factor here. I won't be able to pull anything out, but let me go ahead and to 64 times 3. 64 times 3 is 192 and negative 33. So looking for two numbers that multiply to give me 192 and add up to give me negative 33. 192, let's check. 12 and 21. 21 times 12 is not 63 times 4. Okay, I'm sorry, this is not 192, this is 252. 252. And 12 and 21 would work. 12 and 21, both negative. Why are we making both negative? Because we want them to multiply to positive 252 and add up to negative 33. Now my first number is negative 4. Don't forget the bottoms up method. Divide both sides with the positive 4. First number is 4. A is 4. So divide both sides with the 4x and 4x. The first fraction I can simplify. So this turns out to be 0 equals x minus 3 and 4x minus 21. I would use the zero product property now and find the two solutions, and knowing that they both might not be my solutions. Sometimes they both work. Sometimes only one works in the original equation when we check, and sometimes none of them work. So be ready to plug them back in and check and see which one works, okay? I'm going to start by checking. I'm going to check if x equals 3 works. That's my first one, and it doesn't matter which one you check first. Keep in mind we want to plug them into the original equation, the one we started with, okay? So x equals 3, if I plug in 2 times 3 plus square root of 3 plus 1, is that equal to 8? 6 plus square root of 4, is that equal to 8? 6 plus 2, yes, it is equal to 8. So 3 does work, and x equals 3 we can circle and say this is my solution. Now let's check the next one as well. Next one is x equals 21 over 4. Again, plug into the original equation. 21 over 4. Okay, let me just write the way exactly. 2 times 21 over 4 plus square root of 21 over 4 plus 1, is that equal to 8? This is going to leave me with 21 over 2 plus square root of 425 over 4, is that equal to 8? 21 over 2 plus 5 halves, is that equal to 8? Let's check. That would be 26 over 2, which is 13. 26 over 2, that is not equal to 8. So that means this solution does not work. It's an extraneous solution. 21 over 4 is extraneous solution, but x equals 3 is a solution, and that works. Now we're going to bump it up to a bit harder example where we have two radicals. So two radicals in an equation means you will have to square root twice. Okay, two radicals and another term present means you'll have to square both sides twice. Okay, so this is our second last example. Let's start by, okay, we earlier said that square root, answer to a square root can never be negative. But think about, can answer to difference of two square roots can be negative? Is that okay? Yeah, that should be fine, because the first square root can result in 5 and the next one can result in 7, and the difference will be negative 2. That's okay. So that's not the case to say that it's going to be no solution. All right. So when you have two radicals and another term, your goal is to get one radical on each side. Get one radical on each side. One radical on each side. Okay, so I'm going to get one radical on each side, not sides. So one radical on each side. All right, square root of 2x minus 4 equals negative 2 plus square root of 3x plus 4. Now, I'm going to rearrange the terms a little. I'm going to write it as square root of 2x minus 4 equals square root of 3x plus 4 minus 2. I'm just rearranging the right-hand side to make sure my first term is positive. It's nicer to have your first term positive. It's not incorrect the way it's written, but just it's nice to have your first term positive. Once you have isolated the radical, you're going to square both sides. And when you square both sides, you have square root of 2x minus 4 squared equal to square root of 3x plus 4 minus 2 squared. Now the left hand side is easier because square root and square will cancel each other. The right hand side is a bit more work because you have a binomial in there. So you actually have to write two parentheses next to each other and then FOIL, because you cannot cancel the square root and square root because you have a binomial inside. There is more inside. You're not able to just cancel the square root and the square. Okay, now let's see. We are going to be FOILing. So when we multiply first times first, this will turn out to be 3x plus 4. We concentrated on this when we multiplied the radical expressions. So we've done examples of multiplying a binomial like this with another binomial. 3x plus 4. Outer times outer would be negative 2 root 3x plus 4. Inner times inner would be negative 2 root 3x plus 4. Last times last would be positive 4. Like terms we can combine here. So 3x plus 8, and these are also like terms that we can combine, minus 4 root 3x plus 4. So here's what we're left with, 3x plus 8 minus 4 root 3x plus 4. Okay, that's what my right hand side turns out to be. Left hand side is 2x minus 4. Right hand side is 3x plus 8 minus 4 square root of 3x plus 4. Now, can I combine these anymore? No, because 4 is multiplied with this. 4 is connected to that radical, okay? So don't subtract 4 from the 8. We cannot they are not like terms. Remember, in order for us to be subtract or add, the radicals have to be the like radicals. Here again, I'm going to isolate the radical and then square again. So to isolate the radical, I'm going to subtract 3x from both sides and subtract 8 from both sides. 2x minus 3x is negative x minus 12 equals negative 4 square root of 3x plus 4. To make my life easier, I can go ahead and divide both sides with negative 1, and that's going to leave me with x plus 12, because I could factor out a negative sign or negative 1 from the numerator, equal to 4 times square root of 3x plus 4. Do these problems carefully, do them slowly. There's more chances of making mistakes in these because they're longer and harder radical equations, okay? There's more steps involved. Once my radical is alone, at this point, you might say, hey, your radical is not alone. You have the 4 sitting in the front. I can go ahead and divide both sides with the 4 and deal with the fraction on the left-hand side, or I can just leave that 4 over there. That's totally fine too. I'm going to square both sides. So square and square. Again, squaring the binomial, be extra careful. Don't rush and say that this is going to be x squared plus 144. There's going to be another term, 24x plus 24x, okay? On the other side, when I square, it would be 16 times 3x plus 4. Because 4 gets squared, becomes 16. And root 3x plus 4, square root and square will cancel each other. So now it's time to simplify, and I'm going to make a little more room for myself because I'll be moving into this space here. All right. So from here, I'm getting over there. This would be x squared plus 144 plus 24x equals 16 times 3 is 48x plus 16 times 4 is 64. Now it's a matter of rearranging all the terms, bringing all the terms to one side, and this is a quadratic equation and we'll have to factor it afterwards. So x squared, 24 minus 48x, that would be minus 24x, and 144 minus 64 would be 144 minus 64 is 80. Minus 80 equal to 0. Actually, it would be plus 80 because it's going to be plus 80 because we already subtracted the 64 from it and 144 was positive. Now we're thinking of two numbers. They multiply to give me positive 80, add up to give me negative 24. Well, they're pretty, easy come to my mind that 24 times 4 is 80. 20 times 4 is 80. And negative 20 and negative 4 would add up to negative 24. So so my numbers are negative 20 and negative 4, okay? When I use the zero product property, I get x minus 20 is equal to 0 or x minus 4 equal to 0 gives me two solutions, x equals 20 or x equals 4. Now before I box or circle, I must check my solutions. So I'm going to leave the check work for you, and I'm going to do a quick mental check here to see which solution works. So if I plug 4 in there, again, I'm going to have to plug into the original equation. So for the check work, I'm checking the solution 4 first of all. So square root of 2 times 4 is 8. 8 minus 4 minus 4 times 3 is 12 plus 4. What is that equal to? 8 minus 4 is 4, minus 12 plus 4 is 16. 2 minus square root of 16 is 4. 2 minus 4. So 2 minus 4, 2 minus 4 would be negative 2, which is equal to the other side, which is equal to the right hand side. So x equals 4 does work, because we'll have 2 minus 4, which is negative 4. I'm sorry, negative 2. And that's our right hand side. So the solution x equals 4 does work. Now let's check x equals 20, if that works or not. So I'm going to plug into the original equation. Keep in mind, square root of 20 times 2 is 40. 40 minus 4 is 36. Minus 20 times 3 is 60. 60 plus 4 is 64. And square root of 36 is 6. Square root of 64 is 8. 6 minus 8 is negative 2. So in this case, they both work. Both are going to be my solutions. They both work, okay? And they both are my solutions, and they both work in this case. All right, so let's check another example here. We have one more example, the last one. Go ahead and pause, give it a try, come back, match and check with me if you feel a little confident about it, or you can continue watching. Okay, this is our last example. And again, this one involves two radicals. So let's see, the first step